When Escherichia coli moves in a medium that lacks a concentration gradient, the cell travels, stops, or tumbles, and then continues moving in a new random direction. When the flagella rotate counterclockwise, the flagella form a tight bundle and propel the cell forward in a run. After a brief period, the direction of rotation is reversed, causing a tumble. As cells move up a chemical gradient, the runs are longer than when they travel down the gradient. The overall result is random movement in the absence of a chemical gradient and movement toward a chemical when a gradient exists. Attractant chemicals bind to chemoreceptors called methyl-accepting chemotaxis proteins, located in the cell membrane. The cytoplasmic side of the MCP interacts with two proteins, key W and key A. When the MCP is not bound to an attractant, it stimulates key A to phosphorylate itself using ATP. Key A autophosphorylation is inhibited when the attractant is bound to its MCP. Phosphorylated key A can donate its phosphate to the response protein, key Y. When key Y is phosphorylated by key A, it moves to the flagellum. This causes the flagellum to rotate clockwise and tumble. Thus, a decrease in attractant promotes short runs and tumbling. Key W is an adapter protein, mediating communication between receptors and key A. The phosphate on key Y is continually removed by key Z. The short lifetime of phosphorylated key Y means that the bacterium is very responsive to changes in attractant concentration. When no attractant is present, the cell maintains intermediate levels of key A phosphate and key Y phosphate. This produces a normal run-tumble swimming pattern. When a chemoattractant binds to MCP, the levels of key Y phosphate drop. The lack of phosphorylated key Y results in counterclockwise rotation of the flagella and long, smooth runs. Escherichia coli must be able to ignore past stimulus responses so that it can compare the most recent attractant concentration to the immediately previous one. This is accomplished by methylation of the methyl-accepting protein. Key R continuously methylates MCP, whereas phosphorylated key B removes these methyl groups. When the attractant is bound to MCP, the complex becomes a good substrate for key R and a poor substrate for key BP. The levels of key YP and key BP drop because phosphorylation of key A is inhibited. Removal of the attractant causes the overmethylated MCP to stimulate key A autophosphorylation, and the levels of key YP and key BP increase. This simultaneously induces tumbling and demethylation so that the system returns to a lower level of key A autophosphorylation.